In this video, we are continuing with Chapter 4. This is Chapter 4, Section 5, Similar Figures. In this video, you'll learn to use proportions to find missing lengths in similar figures. Remember that an equation stating that two ratios are equal is a proportion. The three terms that you need to listen for and define in your notebook in this video are polygon, similar polygon, and indirect measurement. When you see them, be sure to pause the video and write the definition in your notebook. A polygon is a closed plane figure formed by three or more line segments that do not cross. Something to remember about similar polygons, that for two polygons to be similar polygons, they have to have corresponding angles that have the same measure and the lengths of the corresponding sides form equivalent ratios. You can use proportions to find missing side lengths in similar polygons. We can do this by doing cross proportions like we have in the last section, to where you have a variable in your ratio or in your proportion and then you solve for the variable. Let's look at these two shapes and try to decide if they're similar polygons. Now, the rules for similar polygons said that for the new similar, first the corresponding angles have to have the same measure. So if we look at the angles, we have 83 and 83, 53, 53, and 44, 44. So we do have corresponding angles. The next criteria is that the lengths have to form equivalent ratios. So if we do write them up as a proportion and then use cross products to figure out, we can find out if these sides are in proportion. So if we have 34 to 51 and then 50 to 75, because when you're doing these, you want the sides that match to be in the same row with each other. Just like when we were doing unit rate and unit proportions, money had to be on the same row as money. Same thing. The side that we're comparing have to be on the same row. So if we do the math and we have 34, that's not a 4. You have 34 times 75 equals 50 times 51. Now I've worked these out ahead of time, so I'm not going to show you the math, but 34 times 75 gets me 2550. And 50 times 51 also gets me 2550, so that also works. So these are similar polygons because they have corresponding angles and corresponding sides. Now let's look at these two shapes and try to decide if they're similar polygons and also solve for the missing measure. So these two polygons would be triangles ACT and ODG. They're called that obviously because those are the letters that the different angles have been labeled with. Doesn't matter what letters you choose, these are just the ones we were given, so the ones we're going to use. So first we want to solve for this side, because we have X centimeters. We don't know how big that side is. So to do that, we're going to write a proportion. So we're going to compare AC and its corresponding side of OD, and then also comparing AT and OG. Alright, now that we know the sides that we're comparing, we can replace our letters with the values for those sides. So AC is X, OD is 50, AT is 24, and OG is 30. So now that we have this, we can simplify the 24 over 30. So now we'll have X over 50 equals, and then we're going to simplify 24 over 30 to its simplest form, which is going to be 4/5 because both 24 and 30 can be divided by 6. Now let's solve this using the common multiplier. So let's think, all right, 50, to get from 5 to 50, I would have to multiply by 10. So to get from 4 to my number, I'll multiply by 10, so that tells me that my x equals 40. If you wanted to do it using cross products, that would also work, and you could do x times 5 equals 4 times 50. That would give you 5x equals 200 divided by 5, x equals 40. It doesn't matter which path you choose to solve the proportion, you're going to come out with the same answer because you're solving the proportion no matter which way you do it. Now, pause the video and try these two in your notebook. Copy the shapes as best you can and write down the original problem and show all your work. Next, we're going to talk about how you can use indirect measurement to measure distances that are difficult to measure directly. You do this by using proportions and similar figures. This is an example of indirect measurement. A 6-foot-tall person standing near a flagpole casts a shadow of 4.5 feet long. The flagpole casts a shadow 15 feet long. What is the height of the flagpole? So we're going to compare the height of the flagpole, which we don't know, over the height of the person. So height over height equals length of the shadow of the flagpole and length of the shadow of the person. So height of the flagpole over height of the person equals length of the shadow over length of the shadow. So now we're going to do our cross products to figure out what this is. So x times 4.5 gives me 4.5x equals, then 6 times 15 is 90. Divide by 4.5. These two cancel out. X equals 20. So the distance of the flagpole is 20. Pause the video and do these two in your notebook. Remember to write down all your work, copy the problems, and show everything you do to figure it out. Check your understanding. Be sure to number all of your problems, label it as check your understanding, copy the shapes as best you can, and show all your work. If it says explain, be sure that you explain. Yes or no is not an explanation.